Hello and welcome to my YouTube channel. This is GCE Mathematics Zone. In the last video, we looked at how to find the gradient of the straight line. But in this video, we are going to look at how to write or how to find equations of parallel lines. So here is an example. Write the equation of the line that is parallel to the line 3y minus 6x is equal to 1 and passes through the point 0,4. Okay. The first thing that you are supposed to do here is to rewrite the given equation. So rewrite the given equation. So this is the equation 3y minus 6x is equal to 1. Okay. Next, you are supposed to find the gradient of the given equation. That's the next thing. You're supposed to find the gradient of the given equation. Now, how do you find the gradient of the given equation? You need to make sure that you rewrite the given equation in the slope-intercept form. You rewrite the given equation in the slope-intercept form in order for you to find the gradient. So the slope-intercept form is the form y is equal to mx plus c. So we need to rewrite this given equation in this form. Okay, so meaning we are going to have, let's rewrite it again, 3y minus 6x is equal to 1. Okay, we need to remain with y alone on the left hand side of this equation. So meaning here the negative 6x has to be removed. And this is negative 6x. So we're going to use additive inverse. So this is negative 6x. So what are we going to do in order for us to eliminate negative 6? We're going to add 6. We are going to add 6x. We are going to add 6x. So add 6x so that when you say negative 6x plus 6x, this becomes a 0. So what we have done on the left hand side of this equation, we also do the same on the right hand side. So we add 6 on both sides so that the equation remains balanced. Okay, hope that is very clear. So here you're going to remain with 3y, which is this one. This will be a 0, so you just say is equal to. So now you're going 1 plus 6x, you have 6x plus 1. Okay. Remember, our aim is to have this form of this equation. Okay. So next, you are going to divide through by 3. You are going to divide both sides by 3 so that you remain with y along this side. So you're going to say over 3 and over 3 like that. Like that. Then 3 cancels. You remain with y. Okay. You remain with y is equal to. So this 3 is dividing everything. So you have 6x over 3 plus, this is 1, so 1 over 3, like this. Okay, next, let's just simplify this. Y is equal to 6x divided by 3 is 2x. It's 2x. Then this, we are going to leave it like this since we can't simplify it further. Okay? Now, in the first place, we said we wanted to rewrite the given equation in this form. And when you look at this, is exactly the form that we are looking for. Now, what you have to know from the previous lesson, where we are finding gradient, m, here you have a 2, and here where there's, so this is m standing for the gradient, but here where you are supposed to have m, there's a 2. So meaning the gradient, so m is equal to, you are going to pick that. The gradient is 2. So this is the gradient. This is the gradient. Now, you are going to use this gradient, okay? Remember, parallel lines have the same gradient. So this gradient is for this equation, the given equation, but because parallel lines have the same gradient, we will also use the same gradient on the given points to find the other equation. Okay, so what you have to know is that parallel lines have the same gradient. Once you find the gradient of the first line, it means that gradient will also belong to the other equation. So since we found the gradient here as 2, we are going to use this same gradient and the given points to find the other line. So this is what we are going to do. We'll use the formula for us to find the other line. We'll use the formula y minus y1 is equal to m, which is the gradient, x minus x1. Okay, that's the formula. After finding the gradient, this is the formula that you are going to use to find the other line that is parallel to this line. So now, look at this, the given points. The first coordinate here is for x and this one is for y. So now, since we have y1 and x1, we are going to put this as the x1 and this will be y1. Okay, so next we'll just replace these values in the equation, in the formula. So we are going to have y minus y1 is, we said, is 4. So we're going to put 4 here is equal to the gradient. The gradient, we found that the gradient is 2. So we're going to put, where there's m, we will put 2. Then x, the value for x here, x1, okay, x will remain like that. Then minus x1 is 0. So we'll put 0 here, like this. Then we simplify, we have y minus 4 is equal to, so we apply the distributive law. We're going to multiply this by everything that is in the brackets, okay, like that. So we'll say 2 times x will be 2x. 2 times 0 is 0. So you have 2x minus 0. So you have y minus 4 is equal to 2x. The 0 is ignored because, yeah, you just ignore the 0. Now remember, we need to rewrite this equation as well in the form y is equal to mx plus c. So we need to rewrite this equation as well in this form. So, okay, so we have y minus 4 is equal to 2x. So our aim is to remain with y alone on the left hand side of this equation. So what do? This is negative 4. So negative 4 has to be removed from the left hand side. We will remove it by additive inverse. So we are, since this is negative 4, we'll add a 4 here, so that when you say negative 4 plus 4, you should get a 0. So what we've done on the left hand side, we also do the same on the right hand side, like this, so that the equation remains balanced. Okay, so we'll have y. This has become now a 0, so we'll only remain with a y is equal to 2x, then plus 4. So this is the equation that is, parallel to this equation here, the given, this equation here, the given